Hello, ladies and gentlemen. Today we are going to do Pre-Calc Lesson 10, Equation of a Line, Rational Denominator, denom is my abbreviation, and completing the square, which I know is everyone's absolute favorite. So let's talk about the equation of a line. Okay, the two most basic equations of line we should know. If we have a horizontal line, our slope, which we know is m, is 0, and our equation is always y equals some number, right? Now, we can remember this if we have an xy coordinate plane, okay, and I was to graph y equals 2, it would be a horizontal line at y equals 2. And if I was to have a little man that was walking along that line, he would be walking flat across this little horizon. It's a horizontal line. Slope is 0. There's no incline, there's no decline. Now the other one is a vertical line, okay, where our slope is undefined. Okay, and the equation is x equals some number. So let's graph on my xy plane. X equals 2 would be this. Now we can remember the slope is undefined because if I had a little guy that tried to walk on this, right, it would be like jumping off the Grand Canyon. Okay, there's no place for him to walk or to stand. His slope is undefined. Now, one of the most basic and important forms of a line is the slope-intercept form. We have y equals mx plus b. Okay, now this is our most important, it's one we use most often, and it's named because we have a slope, which is m, and a y-intercept, which is b. Now, b is a point, it's our y-intercept, and our y-intercept is always something that has an x value of 0 and then some y value. This is our y-intercept. It always has an x value of 0. Okay? So let's do an example. We want to find the slope, find the slope-intercept form of the equation of a line that passes through -3, 2, and 4, -3. Okay? Now, first thing we need to do is our slope, m. We know that our slope is rise over run. Our rise is our vertical, our run is our horizontal. So our rise is y2 minus y1. Our run is x2 minus x1. Now where do I get those x and y's from? In this point, this can be my x1, y1. This is my x2, y2. So my slope, I have y2 minus y1 over x2 minus x1. -3 minus 2 gives me -5, and 4 minus a -3, 4 plus 3, which gives me 7. So my slope is -5 over 7. So far I have y equals -5 over 7x plus b. Remember, please don't write your fractions like this. That is not an appropriate fraction. Okay, this can be construed very, very differently. This is what I want. Now, to find b, we plug in one of these 2 points. It doesn't matter which one. I'm going to pick the first one. This is my x, this is my y. So I'm going to plug in 2 for y, and I'm going to plug in -3 for x to get b. So 2 equals 15 over 7 plus b. So I subtract 15 over 7 from both sides. So b is 2 minus 15 over 7, which we could say b then is 14 minus 15 over 7 if I just made these have the same denominator, which is -1 over 7. So the equation of my line, I have y is -5 over 7x minus 1 over 7. Okay. Slope-intercept form, I have a slope and I have a y-intercept. That's all I need. A couple lessons after this, we will talk about different forms for a line, but right now we're just doing slope-intercept. Let's do another example. Find the equation of the line that passes through -2, 5 and is perpendicular to the line 3y plus 4x equals 2. Okay, we have a lot happening. The first thing I want to do is I want to change this equation into slope-intercept form. So 3y plus 4x is 2. I'm going to bring my 4x over. So 3y is minus 4x plus 2. And I'm going to divide everything by 3. So y is -4/3 x plus 2/3. Now the important thing is my slope I have found is -4/3. If we are looking for a perpendicular line, then we know that we will take the negative reciprocal of this slope. The little phrase we have is parallel same slope perpendic neg recip. It helps us remember parallel lines have the same slope, perpendicular we take the negative reciprocal. So my new line, my slope, this is my new slope, will be the negative of this, so it will become positive, and my reciprocal will become +3/4. So my new equation of a line, I have y is 3/4x plus b. To find b, I take this point, -2, 5. Again, this is my x, this is my y. And I plug in 5 for y and -2 for x. So 5 equals 3/4 times -2 plus b. Now my 4 and my -2, I can cancel that. Don't forget your negatives, so 5 is -3/2 plus b. So 5 plus 3/2 is b. We can change this into one fraction. 10/2 plus 3/2 is b. So b is 13/2. And I plug it into my equation. Up here, y is 3/4x plus 13/2. That is the slope-intercept form, the equation of a line that passes through -2, 5 and is perpendicular to 3y plus 4x is 2. All right, so those are equations of a line. Let's talk about rationalizing the denominator. Okay, so rationalizing the denominator, we need to multiply by the conjugate. The conjugate, what is the conjugate? The conjugate has the same number values, but opposite signs. So here's an example. If I had 1 plus the square root of 2, my conjugate is 1 minus the square root of 2. okay? And we multiply by the conjugate on the top and bottom. Parent evenly. Whatever you do to the top, do unto the bottom, okay? The whole reason we rationalize the denominator is because we have something like this in my denominator. We don't want radicals in the denominator. It's very ugly math. So we need to rationalize it so we no longer have those radicals. So let's do an example. Example 3, simplify. 4 plus radical 3 over 2 minus 3 root 3. I have a radical in the denominator. That means it is not simplified, so I need to simplify it. And I do so by multiplying by my conjugate, which is 2 plus 3 root 3. And I multiply that on the top and the bottom. Now, let's put in our appropriate parentheses. I'm just going to look at my denominator now. 2 minus 3 root 3 times 2 plus 3 root 3. If we were to FOIL this out, we do the first. 2 times 2 gives me 4. Outside, so plus 6 root 3. Inside, minus 6 root 3. And last, minus 9 times 3. How did I get 9 times 3? 3 times 3 gives me 9. Root 3 times root 3 gives me 3. Now what we notice about this is these terms cancel, leaving me with 4 minus 27, which is negative 23. Now, you don't have to do this little side note every time, because if we notice, what I have here is I have my first term squared, 2 squared, minus my second term squared. So, my new denominator, I have negative 23. On the top, I do the same thing. I first multiply my first, so 4 times 2 gives me 8. Multiply the outside, so plus 12 root 3. Multiply the inside, plus 2 root 3. And multiply the last, plus 3 times 3. Again, root 3 times root 3 gives me 3. Now I need to simplify. I'm going to combine my non-radical terms, so 8 plus 9 gives me 17. Then I'm going to combine my radical terms. I will have plus 14 root 3 all over negative 23. Now you can leave your answer like this. I am going to make it a little more simplified. This is absolutely acceptable though. I'm going to bring the negative to the top, giving me negative 17 minus 14 root 3 all over positive 23. They are the same. Now, often you will see this broken into two fractions, negative 17 over 23 minus 14 over 23 root 3. I will accept either form. Okay, we'll get into later when this is not acceptable, but this is okay with radicals. And again, we look to see, can we simplify any further? No, we cannot. Now, just as before, we couldn't have a radical in the denominator. We also cannot have I in the denominator. So, this is our complex conjugate. Okay, which is very similar. It has the same values with opposite sign. And we multiply the top and the bottom by it. Now, this is an example of a complex conjugate. If I had 2 plus 3i, my conjugate is 2 minus 3i. Okay? So let's do an example. Example 4, if I was to simplify 2 minus I cubed plus 2I to the 5 all over minus 2I plus 4. Okay, we got a lot happening right now. What I want to do first on the bottom is I want to put this in standard form. 4 minus 2i. Remember, you have your real portion, then your imaginary portion. And on top, I'm going to rewrite it as 2 minus I squared I plus 2 times I squared I. Right? If we have two things of the same base being multiplied, we add their powers. So I cubed, I can write as I squared I. I to the 5, I can write as I squared I. Now, we know I squared is negative 1. So on top, I will have 2 minus negative 1 times I plus 2 times negative 1 times negative 1 times I. My bottom stays the same. I continue to simplify. Okay, this gives me 2 plus I. Negative times negative is still a positive, so plus 2i over 4 minus 2i. So I have 2 plus 3i over 4 minus 2i. Now I'm ready to multiply by my complex conjugate. My complex conjugate, I have 4 plus 2i over 4 plus 2i. Again, make sure you multiply the top and the bottom. Now let's just look at the denominator. 4 minus 2i times 4 plus 2i. I multiply my first, 16, my outside, 8i, my inside, minus 8i, and my last one I'll have minus 4i squared. Woohoo! Now, if we notice that 8i minus 8i cancels, leaving me with 16 minus 4i squared is negative 1. So I have 16 plus 4, which gives me 20. You don't have to do this step every time, because again, we can look and say 16 is my first term squared minus my last term, which is minus 2i squared, which ends up giving me the 16 plus 4. So back up here, my denominator becomes 20. And on top, I multiply and FOIL it out. So I have 8 plus 4i plus 12i plus 6i squared. Now I continue to simplify. 8 plus 4i plus 12i gives me 16i. And this becomes plus 6 times negative 1. My denominator is just going along for the ride. So I have 8 minus 6, which gives me 2 plus 16i over 20. This is not an acceptable way to leave your answer. You have to separate it into a plus bi, your real portion and your imaginary portion. So my real portion here, 2 over 20 plus 16 over 20i, my real, my imaginary. And we have to simplify. 1 over 10 plus 4 over 5i. That is an acceptable answer. You have to leave it in a plus bi every time. All right, let's move on to everyone's favorite. Completing the square. Okay. Now, completing the square, what we do is it's rearranging a quadratic to find the zeros. The zeros of a function are the x-intercepts, which are the x values that make the equation equal 0. So, as an example of a 0, if we had x minus a times x minus b equals 0, we know that if I plugged in x equals a minus a is 0, this would be true. And if I plugged in b minus b is 0, this would be true. These are my zeros. They're also my x-intercepts, a0, b0. These would be my x-intercepts. Now, completing the square, I'm just going to show you by an example. Example 5. Okay, we want to solve minus x plus 3x squared equals negative 5 by completing the square. Completing the square we're going to do in many different facets this year in pre-calc. So if you are unsure of completing the square, make sure you come in for help and we can get it figured out. Now the first thing I want to do is I want to rearrange this. 3x squared minus x equals negative 5. And I want to have a leading coefficient of 1. So I'm going to divide everything by 3. Makes my life easy. So x squared minus 1 over 3x equals minus 5 over 3. Now I draw my boxes. b over 2, b over 2 squared. This goes in parentheses. That's what we plus or minus. Now, the b is my b term here. The negative does go with it. Okay? So negative 1 over 3. If I divide that by 2, I have negative 1 over 6. And square it gives me 1 over 36. Now, there's a little plus under this box because I'm going to add 1 over 36 here and parent evenly do it on both sides. Okay? So, over here I have x squared minus 1/3 x plus 136. I've now made this into a factorable side of my equation, and the parentheses here tell me what I factor it into. X minus 1 over 6 squared equals, now, negative 5 over 3 plus 1 over 36. I am going to do in a calculator. I hope you can see my calculator. I'm going to do parentheses negative 5 divided by 3 plus parentheses 1 divided by 36. Enter. Now it gives me this crazy decimal. That's not what I want. So I press math. The first option says frac. So I press enter. It will say answer arrow frac. And I press enter again. And it gives me my fraction, which is negative 59 over 36. Now I have successfully completed the square, but I have to continue to solve for my zeros. So from here I'm going to take the square root of both sides. The square root on this side cancels my squared, leaving me with x minus 1 over 6 equals, over here I will have plus or minus the square root of negative 59 over 6. Square root of 36 is 6. Now we know if we have the square root of a negative number, I can rewrite that. So I have x minus 1 over 6 equals plus or minus the square root of 59 over 6i. And I'm going to add my 1/6 over, so x is 1 over 6 plus or minus the square root of 59 over 6i. And those are my two answers. Make sure you remember your plus or minus. This is the most important part, that you remember your plus or minus. And make sure you're drawing your boxes. Okay, this is a very good way to continue to have your materials organized as you're completing the square. And that is all I have for you today. Remember, if you have any questions, bring them to class tomorrow.